下面呢，我们开始我们的下午的第一个 talk。让我来这个隆重的介绍一下我们的这个 speaker， Jason Chen。他的简历呢是用英文的，所以我就念一下给大家。So Jason Chen is currently a developer advocate at Google, where he works on ensuring that developers for the Android platform are successful. He previously led the developer support team for Google Checkout, which is another Google product. Prior to joining Google, Jason worked at IBM and Virgin Software. 让我们大家用掌声热烈欢迎 Jason.
Thank you, Bob. I'm going to apologize ahead of time by saying that I don't speak Chinese, I don't speak Mandarin, I don't speak Cantonese, so I will be giving my talk in English. So I'm here today to give an introduction to Android, and we'll get started. So first thing I want to cover is give a little bit of background. I think that Marissa in the keynote today covered a bit about why we think mobile is important. I'll give a little bit of background on that. I will talk a little bit about the Open Handset Alliance and what that means. And then we'll get into the meat of my presentation, which is talking about what is Android at a technical level, and then bring you up to date with the latest news. So hold on for a second. They're telling me I can use this. No, there you go. So the thing that Marissa mentioned about growth was growth in PC user. What? No, it's my slide. So what I wanted to point out was one thing in terms of the worldwide market for both mobile and for PC-based internet usage. So this is a slide that illustrates the growth in both mobile users worldwide, which is the one in blue. And as of 2007, there were about 3.3 billion mobile phone users worldwide. And compare that to PC-based internet users, and which is in orange. And in 2007, we had about 1.1 billion. So worldwide, there's about 3 times as many mobile phone users as there are PC-based internet users. So you can imagine that in a market that big, that it'd be important for Google and for many other companies. So in order to bring Android to market, one of the things that Google did was it worked with 34 different companies, or 33 other companies, to form the Open Handset Alliance. And the Open Handset Alliance consists of 5 different types of companies. The first being, of course, the mobile operators, companies like China Mobile here in China, as well as others throughout the world. There's also handset manufacturers. So there's Motorola, HTC, Samsung, LG. In addition to that, there's also software vendors. So these are companies that provide software that are going into the Android platform. There are also semiconductor companies. So these are companies who are working to bring Android to their chipsets. And then, of course, last but not least, there are commercialization companies. So these are companies that help operators and vendors, or operators and handset manufacturers, port Android and bring it to market as a device. So that's just a little bit of background. What I really want to get into today is talking about what is Android. And the way I thought I'd start would be with the classic sort of stack system diagram. And some of you may have seen this if you look through our materials that are online. But I'll talk through a little bit of it for the benefit of those of you who may not have seen it. So at the bottom, in terms of the stack, is the Linux kernel. So Android uses the Linux kernel largely as a hardware abstraction layer, but also because it provides us a couple of things. The first is a well-known driver model, also a memory management system, a security system, as well as a networking stack. And next in the layer are libraries. So these are system libraries. They're mostly written in C, C++. These encapsulate some of the rich functionality that we wanted to include in the Android platform. Things like SQLite, which is a small embeddable database. Also WebKit, which powers the Android browser. It's also the same rendering engine that powers Safari and also the iPhone browser. Also up here you'll see Surface Manager, OpenGL, ES, and SGL on the left. Those all have to do with our graphics stack. So OpenGL ES, of course, we use for 3D, and then SGL is our 2D primitives library that we have. The other thing you'll see up here is libc. So libc is pretty standard across various platforms, but libc on Android is something that we've done custom. We've what we call, it's a library that we call Bionic, and we've written it really to be both efficient and fast on an embedded device. Because really, when you're running on a mobile phone, you have limited memory, you have limited CPU cycles, and so you want to do everything as small and as fast as possible. Next is the Android runtime. So this consists of two pieces. The first being the Dalvik virtual machine. It's a custom virtual machine that we've built. It's not a Java virtual machine. And it's something that Dan Bornstein, who is the tech lead for Dalvik, will be getting into much more detail about in the session later this afternoon. I think it's at 3:30. In addition to the Dalvik virtual machine, there are the core libraries. The core libraries are largely what a Java programmer who's used J2SE would largely expect. So it's most of the J2SE APIs, although not all of them. Remember, we're not claiming this to be a Java platform or technology. So what we are using is the Java language. And what you do is you write Android programs in the Java language, and they get converted into Dalvik bytecode and run on that Dalvik virtual machine. A lot of those details Dan will get into in his talk. So next in the stack is the application framework. So for you as application developers, this is where you'll interact with the system. The application framework provides not only a rich set of APIs for doing a variety of different things, but there's also system services and managers as well. So if the hardware supports it, when your application is running, you can get access to things like location from the location manager. There's also things like the notification manager, which you can think of kind of as a way for you to set and also show notifications to the end user. So if you want to, remind the end user that it's noon and he has an appointment, you can work through that system service to do that sort of thing. And then last but not least, and what I think is most important, especially since I work with developers, are the applications. So we've got home, contacts, phone, and browser up there. Those are some of the applications that come with the platform. But the last dot up there is really meant to represent all of the applications that you, as developers, will hopefully be creating for the platform. And my point in talking about this really is that the home screen, even the browser, contacts, all of those applications that come with the platform use the same exact APIs that are available to you as developers. So the underlying point really being that there are no hidden or privileged APIs in the platform, and you as application developers get the same access as what's available to application developers building the platform. So that's a really brief overview from a high level, from a systems level. If you want to know more kind of about the system libraries and the Linux kernel layer, Patrick Brady is giving a systems level talk right after this one. We'll be talking or giving much more detail and much more depth about that. So what I really want to spend the bulk of my time talking about are the basics of an Android application. I have about 45 minutes with all of you, so I don't expect all of you to take away a mastery of developing Android applications. But what I do want to do is introduce the important concepts. So to start, applications really have four major building blocks. There's what we call activities. There's also intents, or intent receivers, services, and content providers. The descriptions of each of those are up there. Just briefly, an activity is you can think of it as a UI or a screen. An intent receiver is a way for your application to set and respond to notifications from other applications and from the system itself. Services are faceless tasks that run in the background. And content providers enable applications, your application actually, to share data with other applications in a structured way. What I'm going to focus on is activities, because activities are really the part of your application that your end users will interact with most. So just to define some terms, think of an activity as a molecule or a discrete chunk of something someone can do. Think of it as a discrete chunk of functionality. A task, which I'll also get into, all these terms I'll get into talking a little bit more about in the next couple of slides. A task, think of it as a collection of activities, so it's a group of activities. A process, when I talk about process within the Android app framework, is really maps to a standard Linux process. And then an APK is a file that contains your application's code and the resources that you bundle up with it. So things like images or sound files or whatever else that you want to include with your application. So all those components fit together in a hierarchy kind of like this. And the first part that I'll talk about are, of course, are activities. And so activities are a couple of different things. First, they're a concrete class in the API. So there's an activity class that when you're building your application, you'll extend to create your own activity. And even though the activity component, I said earlier that they're typically associated with the screen or some sort of UI, you can also create activities that don't have a screen. Also, as I mentioned earlier, activities are an encapsulation of a particular operation, something that your end user is trying to do, whether it's reading a specific mail message or picking a photo or surfing the web. Think of an activity as a particular thing that your user is doing. There are also a couple other things about activities. They run in the process of the APK that installed them. So I mentioned processes before. You can see if an activity is associated with the APK and it runs in the process that belongs to that package file. And also they have an execution context, which provides you as an application, or in your application, an idea of, okay, well, what's going on in the system, and hooks into doing other things. So I mentioned also that tasks. I also mentioned tasks, and tasks are a collection of activities. It's really more of a concept than a concrete API or class. And so what you can think about, and the reason this exists, and the reason I think it's important, is that the way that the Android application framework works, your application can actually start other activities. And so if you start multiple activities, be they in your own application or across applications, what they end up doing is they end up being bundled into, or they're grouped in what's called a task. And that task is how the system manages the order of the screens. Because as you start new screens, they stack up in a stack. And as the user navigates backwards through them, they come off that stack. And that task, each task has its own UI history or screen history. And so that's part of the reason why we have this notion of tasks that you as application developers should be aware of. But also, because there's such fluidity between components in the Android framework, I think end users will really think of tasks as you might think of an application on other platforms. Because there's no transition. There's transitions between activities, but it's seamless to the end user whether one application is being started or another. All they see is that a new screen pops up on the screen for them. So kind of next in this hierarchy diagram are processes. So like I mentioned earlier, Android processes, from the framework perspective, map to a Linux process. And by default, each process, there's one process per APK. But as you see on the right, there are exceptions where you can have more than one process. And usually usually you'll start a service or you can start a service in a separate process. And there are good and bad reasons for doing that. But I want to point out that that's a possibility. Since we're talking about processes, the other thing I'll talk about are threads. By default, every process has one thread that starts, and that's the main thread through which we interleave events and also UI updates. But Android applications can be multi-threaded. So if you want to start or do a lot of work in your application, say calculate the 100th digit of pi, you probably don't want to do that in your main thread because the UI might stop responding. So you start a second thread, do the computation in there, and then when that finishes, have that post back to your main thread so you can update the UI with that calculation. In addition to that, a process is started and given a unique user ID. Let me rephrase that. Every APK is assigned a unique user ID, and that maps to the developer that created that application. So what this means for your applications is that they're siloed into their own process because they're owned by a separate user, and those processes also remain running, even if the system or you as an application have stopped and finished your activities. So processes will sit around, and part of the reason why we do that is because it makes it easier, just in case the user ends up going back to that particular application, for us to start the activity again. So it just saves us some overhead in terms of leaving that process running. And then last but not least, of course, are APK files. Like I mentioned earlier, APK files are the way that are a bundle or a file that contains your application's code as well as any of the resources that you are bundling with that application. And really, you can think of it as a glorified zip file. That's how you distribute and install your Android application on a device or on an emulator. So that's a kind of a brief introduction to what I think are the important concepts about Android applications. What I want to give you a preview of and show you some screenshots of now the developer toolchain. Because really, I've told you all about the things that you can do and the pieces that fit together. Well, how do you put them together? First is the Android emulator. It's a QEMU-based ARM emulator. It runs the same system image as a device. So when you move from building and testing on an emulator to an actual device, there's very little in the way of differences. So you can expect that things will run similarly in the emulator as they will on the device. And because the emulator runs the same system image and the same exact code as it would run on device, you can use the same exact tool chain when you're developing and debugging on an emulator or on a device. So it's rather seamless when you move from one to the other. There's also an Eclipse plugin. We've built an Eclipse plugin to encapsulate and provide a nice UI for all of the command line tools that we've built for creating, compiling, and packaging Android applications. And we picked Eclipse, I think, because there were a lot of developers or engineers on the team who used Eclipse. And it also seemed like a pretty straightforward place for us to build a plugin. That being said, if you don't like Eclipse, you can certainly use NetBeans or IntelliJ or any other, or even VI, if that's how you like to develop your applications. This is a shot of what it's like to debug an Android application. As you can see, like in Eclipse, it's pretty much the same. You're writing your application using the Java programming language. You've got the same standard sorts of things you'd expect. You can set breakpoints, you've got your call stack, you can examine your variables. In addition to debugging, we also have a tool called TraceView that helps you figure out, and optimize the performance of your application. So you can figure out where you're spending the most of your cycles. You can see, kind of the call stack hierarchy there. You can see in the timeline across the top, what we do is we color code where execution time is spent in the various files and in the various places in an application. So that's a bit about the tool chain. The next thing I want to get into talking about is what is open mean? Because really it's called the open handset alliance. It's not the closed handset alliance. So I want to explain a little bit more about what Android as an open platform means for all of you as developers. So when you think about mobile and interactions in mobile for developers, there are really three key players in that kind of relationship. There's the mobile industry. When I say mobile industry, I mean handset manufacturers, network operators, and the like. And really, when we say Android is open, for them it means a couple of things. The first and foremost is that the software stack will be open sourced under the Apache 2 license. And for the mobile industry, they can take that source, they can put it on, their devices free of charge because we're providing it, under the Apache license, and they can do what they want with it. So we're providing them a common platform for building their next generation devices and deploying their next generation services. Also, a couple of logistical points. The source is not yet available. When we say that Android is open, or will be open sourced, the source itself will be available after the first devices are on sale. So, and then once that's open source, anyone will be able to take it and build a system image, whether it's a device manufacturer or a hobbyist who has some ideas about how they think they can change Android. So that's the industry. The next piece in this triangle are users, and end users who will be interacting with applications and with services that operators are providing. For users, when we say that Android is open, it boils down to really one thing, and it's that users have control of their own experience. And that manifests itself in two ways. The first is that they control what gets installed. So as an end user, if you're using an Android device, you'll be able to install whatever applications you want. And then once you have those applications installed, the other thing that you get to do as an end user is you get to choose the defaults. So if you think that the web browser that's provided with the handset that you bought wasn't good enough and you want to download a different one, you can, by all means, you can do that. And you can set that to be your default browser. So as an end user, that's how Android manifests itself as being open. And then last but certainly not least, developers are the last part of this sort of triangle. And for developers, Android being open means a couple things. The first is that you don't need to ask permission to ship an application. And just like, and we think that this is having a more open model will help you as developers be much more innovative and bring that innovation to end users much more quickly. And we've seen where open platforms like this benefit everybody on other platforms. And namely, the biggest one being the web, where, on the internet, you don't have to ask permission from anybody to put up a website. Likewise, we think that with Android, one of the key ways that we can bring that similar sort of attribute is by not requiring application certification. The other thing, which I alluded to earlier when we talked about the stack diagram, is that there are no hidden or privileged APIs. So if you want to access or replace an application that's provided by default in the platform, you can do that because there's nothing that's hidden from you as application developers. So that's kind of two policy decisions in terms of how we're making Android open as a platform for you all. The other way that Android's open for application developers is at a technical level. And the way that I like to summarize it is in three concepts. And they are integrate, extend, and replace existing components. So I'll explain each a little bit more. So when I say integrate, what I mean is that you as an application developer can integrate with other components that are on the system. So let's say and the example that you'll see up here is the browser. In the browser, I've searched for 1600 Amphitheater Parkway. That's the address for the headquarters of Google in Mountain View. And the search results have come back, and you can see I've clicked on the link that's up there to go to Google Maps to see where exactly the headquarters are. And what the system has done is it's popped up a dialog to prompt me as an end user to select an activity. Do I want to see the map in the browser, or do I want to see it in Maps? And remember, the browser and the Maps application on the Android platform are two separate applications. But because Android as a platform is open, the browser is able to integrate with the Maps component. So if I were to select the map activity here to view the address, what I would see on my screen is the map activity, the map application startup, and I'd see the location of Google's headquarters. So that's just that's one example of how you as application developers can leverage existing functionality that other developers and other programs are providing on the system, and you can integrate with them. The next concept that I mentioned, or the next concept is extending, and this is pretty straightforward, I think. And the example that I'll put up here jumps back to Maps. But what you see up there is an application, actually, it's called Call a Cab. It's one of the top 50 from our Android Developer Challenge. And what they've done is they've taken the map view component that we provide in the platform, and they've customized it. They've extended it, actually, to include all sorts of pieces and UI that they wanted to provide to make it easier to call a taxi from their application. So that's extended. And the map view is not the only component on the system that you can extend. There's also things like web view, which is you can think of as a web browser component that you can embed in your own application. And then, of course, the last concept is replace. So the way I'm going to illustrate this is by showing you a contacts application. So this is the contacts application that's included with the platform. And, it's okay. But if you didn't like that, or if you as an end user thought, as a developer, you thought you could do better than this, you could maybe create something like this. This application is called Phonebook 2.0. It's also one of the Android Developer Challenge Top 50. And they've created what they think is a better take on a phone book. And so if I were, as an end user, were to install this on my device, I could replace the existing contacts application as a component. And the way you'd see that is really that, if I were trying to, let's say, save a phone number that I got from the browser and add it to contacts, well, if I hit that orange button there and say add to contacts, I'm going to go back into the old or the default contact or address book. Instead, what you'd see is it would, when you click it, it would go into Phonebook 2.0. So at a conceptual level, really that means that if you think you can do better than some other component that's on the system or some other application, you as developers should create that and make that available to your end users because they can swap in and out all those types of components. So we've talked a little bit about, Android's open and it's open as a platform, but it brings up some questions. What about security? If the platform is so open, how do you keep bad things from happening and keep the end user in control of their phone? There's a couple things that we do, and there's a couple things that we do. The first is in the runtime environment. Like I mentioned earlier, every application is given a unique user ID. And the implications for that are, well, actually not every application. There's 3 exceptions, and they're system-level services. There's the init process, which is standard in Linux. There is a process that we call Zygote, and that's related to Dalvik, and Dan will explain a lot more about what Zygote is. And then there's also the main application framework runtime. And all 3 of those are the only 3 processes that don't run in a unique user ID. Everything else is sandboxed into its own user ID and process. And because they're in their own process, every application that's installed on the system only has access to its own data. So if if your application writes out files to the system, you're the only application that can get access to that data. The other thing being that, I mentioned content providers earlier. Content providers and intents and other constructs in the framework are the only way that applications can possibly get access to other applications' data. And by doing so, what that means is that they're defined and also explicitly expose APIs or ways that you as a developer can expose your data, but also get access to other applications' data. In addition to the runtime environment, there's also an application permission scheme, and what that really involves is for your application, if you want to do something that might possibly harm the user, so say make phone calls or send SMS or get access to the address book, for your application to be able to do those sorts of things on the platform, you have to request permission in your application manifest file so that the system can grant that permission to your application. And by having to ask for permission, what we do with that information is we show the end user when they install your application that it's asking for those particular permissions. So, and the reason we do this is because let's say the user you're downloading a game. And when you're installing it, the system tells you, oh, this game is asking to be able to make phone calls and send SMS and also access your address book. Well, you might think that was a little fishy if that application is a game. So the guiding principle there being really that we want, since the end user is in control we want to make them aware of the implications of installing, this new application on your system. So that's a bit about security. So what does this all mean for you as developers? I think it's a couple of things, and I can sum it up in this way. The first is that you're going to develop your applications using the Java programming language, and also that there is a rich set of APIs and system services that we think you as application developers will be able to take advantage of to create innovative applications for the platform. And those applications, I think, are what's going to help ensure the success of the Android platform. And we hope that by providing an open platform where all of you can do crazy things that maybe we haven't even imagined of, that in the end, everyone will benefit from having a more innovative and open mobile experience. So, just some latest news. We announced Android back in November of 2007 and released the first early release of the early look at the SDK at the same time. And then in early January, what we did was we started accepting submissions for the Android Developer Challenge. And then in mid-February, we released an updated SDK. And that's the current SDK that's out on our website and available for you as developers. And then beyond that, and then in April, we got almost 1,800 total submissions for the Android Developer Challenge. We were really blown away by the number and the quality of the applications that came in. And we got applications from all around the world. Even I think China was one of the top places that we got applications from. And in mid-May, we announced the top 50 of those applications that we received. And now what those top 50 are doing is they are going back and refining their applications for further use, and also for us to be able to judge and find the top 20 of those. So I mentioned the Android Developer Challenge. What's that about? It's really the goal of the Android Developer Challenge is to help developers, you as developers really, turn those ideas that you have in your head into great code. So we want to see you take those ideas that you have and make them into applications that people will be able to use when devices are on the market. And so how we're doing that is that we're giving away $10 million. And there's Android Developer Challenge 1, and then there's Part 2. We've already closed Part 1, and we're giving out a total in Part 1 of $5 million. And then when Part 2 starts, which will be after the first devices are available, you'll be able to, we'll start that back up, and we'll be giving away the rest of the $10 million, which will be another $5 million. So hopefully that's gotten you interested in Android. What I want to point out is an online resource. We have some of not all of the resources, but some of them localized into Chinese. And it's available at this address. And I believe these slides will also be going up online after this talk at some point. And so with that, what I want to do is open this up for question and answer. So I think, do you want to run around with the mic? Maybe a microphone? Wireless mic. Okay, so we have the wireless mic, so if you want to raise your hand, he'll make your way, or that person will with the microphone will make their way to you, and you can ask your question.
下面我们有10分钟的时间给大家提问，大家踊跃提问啊！现在机会难得。
我知道 Android 是一个很开放的一个平台，但是它好像只提供了一种 API， 就是 Java 的 API。这好像又不怎么 open。我们知道，如果要做更丰富的应用的话，应该在多种层次上，比方说 C、C++或者是动态语言上都提供一些 API， 这样才会有更多的应用，然后也会有更多的用户，这样才会形成一种良性循环。那 Google 在这个问题上，它是一种什么态度？它有什么这样的开发计划吗？或者说他们是怎么考虑这个问题的？
The question is, Android is the open platform, but it only provides one development language, which is Java. But we think that in order to make good applications, it should provide development languages in multiple levels, right? And we just wonder if Google has any plan in supporting other development languages.
So that's something we've heard a lot from developers. It's something I think the team has thought about. But right now, the bulk of the work has been into Java. And a lot of the reasons for that are practical and pragmatic reasons. Because there are a whole lot of Java developers out there. And many Java developers who are familiar with the language, who have been building for the J2ME platform. So we wanted to provide a familiar environment for developers to build on Android as well. So it's something I think the team will think about and continually evaluate as to whether other languages could be used with the platform. But for now, it's only Java.
I have two questions. First of all, I want to know why use the word Android as the name. Secondly, I want to know why people use Android but not use Windows Mobile 6 edition. Thank you.
Sure. So I wasn't around when Android as a company got started, so maybe Dan can help me here, but my guess as to why the company was named Android was that Andy had the Android.com domain name, and it seemed like a good name to give to a company. Also, Andy Rubin, who was one of the co-founders of the company, which was started outside of Google, and then was bought by Google. Really likes robots, so probably had to do kind of with those two things. So, and then your second question, I think, was about why would somebody build on Android versus, say, Windows Mobile or some other platform. For a developer, I think it's really about how open the platform is and how much functionality I think that we're providing in the platform. The other thing I think is that because we can provide a platform for free, what you'll see is that many devices will come to market with the same Android platform and the same pieces in that platform because we're providing the full stack. So as an application developer, you won't have to write an application specifically for one device and then another one for a separate device. You can write it once for the Android platform and then have it work on many, many devices.
I have two questions about security. Okay. The first one is you talk about the developer can replace the core system components of Android to do their own software. Sure. And what if some software that it replaces everything? It replaces home screen, the contact book, everything, and the users are not able to change it back. And the second question is, you use the you check the security of the software every time the user install it, and what are the differences between this method and the Microsoft's method uses Windows Vista, which is every time users run the program?
Okay.
Thanks.
So let me take those two in reverse order. I think the difference is simply in philosophy, right? We want to make the platform open for end users, but also, the platform needs to be secure. So we think we strike that balance by showing the end user at install time, when they install the application, what that application might do that might be sensitive. I think, and in that way, we don't have to show them a notice every time they try and run that application that, hey, this is going to do, something like accessing your phone. or it's going to try and get data from over your GPRS condition. Because we wanted to also, I think, provide the end user a good experience, and then having to say dismiss a dialog every time they run an application might not be a great thing. And then the first question that you asked was, what happens if an end user, or if a user installs an application that takes over, replaces a lot of different components? Well, just because they install an application doesn't mean that that application can take over the home screen. The end user has to set that by default or start that application before it runs. So, they could possibly say run that application the first time, but not set it as the default, say, home screen. And if they saw that, it took over the home screen and didn't let them do anything else anymore, they could say restart the phone and still start back up into the home screen you had before. And you could, choose to either delete that application or just never start it again. Yeah. The other thing is that you can also reinstall the whole system. So you could, reset it to the factory settings, which would remove that out.
Okay, and now I have a question. As we all know, the Android platform has a browser, it's a developer-based webkit. My question is, how can I customize the Android platform browser? Now, if we cannot do this work after the Android handset ship, and we will do this work, I want to know.
Okay, I think your question was about. It was from the perspective of someone who wants to create a device. Is that correct?
My question is, how can I customize the Android platform browser?
Right now, how can you customize it now? Well, right now what we're providing is an SDK for application developers. I think and that SDK includes an emulator. So you could use that emulator and to help you develop your applications. You can install them in the emulator and see how you can replace the different components. Customize the sort of experience that you want to provide your users. And then once devices are on the market, you can make your applications available to for real to devices, and users will be able to use it. Really, the question over here. Okay. Oh, sorry. We'll take one from this side of the room.
Hello, Jason. I have a question. I can that there are so many location-based mobile services in the top 50 application at Challenge 1. Is this the main feature of Android? Thank you.
Well, it's not the main feature, but I think it's a feature that developers are really excited about. I think that it's something that developers and also end users always get excited by thinking about, well, what could my application do if it knew about my location? So I think it stands to reason that there would be a lot or some or a good number of applications in the top 50 that would contain a location component. But by no means is Android just all about location. I think the important, there are a lot of other features that are in the platform, things that I couldn't get into today, and also aspects about it, like things like the openness that are also very important. So it's one, but not the only piece. Back over here.
Well, I love Android personally because it is very open, but as I know, the biggest concern for any user is the interface. We see that iPhone is doing very well because it has a very fancy interface. So how about Android? The second question, please. The second question is that, as we know, for mobile device, the power management is a very, very important issue. So is there any facility that Android has provided for mobile device?
Okay, so let me take them in reverse order. Your second question was about power management and how application developers might be able to know about that and the performance. I don't think we have any specific tools that will help you gauge, how much will this application take down in terms of battery life. But what we do is provide a variety of tools for measuring performance and understanding how your application behaves in the system. And for all of you as developers, the important thing is for your application to not do a lot, or to do as little as possible, so that you use as little of the CPU as possible and as little of the screen or sound or whatever you do, so as to preserve battery life. So the less you can do, the better. And then the first question was about, I think you asked about UI and the importance of that and what that means for the Android platform. Well, remember the home screen, which provides the main UI in terms of what end users or users will see, is just another application. So if you think as a developer you think you can do better than the home screen that we provide, and that we've demoed in our videos, you're certainly welcome to do it. I think we're developing a pretty compelling home screen, and we've shown that in videos. I think the one that you can see is at Google I/O, from Google I/O. So we think we'll have a good home screen, but if you think you can do better, you're certainly welcome to do it. And over here. Up along the wall.
Okay, my first question is that we all know that Motorola uses Linux kernel on their phones too, but I know little about Motorola's Linux kernel, but I'm very much interested in this Android. What is the biggest reason that you think Android will beat other Linux kernels on telephones?
Okay. Well, I'm not a systems level sort of expert. I spend most of my time up in the application framework. But you gave me a perfect segue. The next talk that we'll be giving about Android in this room is Patrick Brady's talk, which will be about the system level, kernel level sort of details about Android. So if you stick around, you'll find out about all the different things that we're doing that are different and unique with respect to Linux and systems level issues. And in particular, all of those changes, because the Linux kernel is under GPL, are already out and available. So if you want to examine them, you can take a look at them.
I got a second question. Is that according to your speech, that I know that Android is configurable, is a totally configurable system. Is that right?
It's an open platform. Yes.
And do you really think that totally configurable system is good to end users? Because I think maybe some users wouldn't like to spend much time on the configuration of their system. They just want to use it.
Yeah, I think that's an accurate observation. I think there's an important difference between an open platform and a totally configurable system. And by default, or not by default, but I think when manufacturers and operators bring a device to market, they're not going to just leave it as a blank slate for end users to have to configure and set up themselves.
But sometimes I think some users will misoperate and they will kind of like probe the software system. Is that possible?
I don't know that you could break the system, because as an end user, really all you can do is install new applications. It's not, if you're thinking of this as a Linux system, where you do package management and have dependencies and these sorts of things, one of the things Patrick's going to say in his talk is that Android is not Linux. It uses the Linux kernel, but Android as a runtime is everything above the Linux kernel. So don't think of it really as like a Linux system. Think of it as a mobile platform that uses Linux to provide basically what amounts to a hardware abstraction.
Actually, I want Android to be to have a very good UI.
Well, we think we're developing this. Are we out of time here? I think we're out of time here. So one last question. Over here.
Jason, just now you mentioned that you have announced the top 50 applications on Android. So I hope to know whether you have interest to integrate other applications with other companies together. Thank you.
Well, I think your question about if we're going to integrate products from other companies into the platform?
Such as some applications now not used on Android, such as handwriting solutions or OCR solutions.
Well, the thing about Android is it's an open platform, right? And it's an open system. So if a manufacturer, when they're creating an Android device, wants to install certain applications, they can do that. End users can do that as well. Well, what I do in my work is I work with developers like you, also companies who might be building applications for Android, to make sure that they help them bring an Android application to the market and get it ready for devices later this year. So I think you'll see applications from lots of different companies.
Yeah, thank you.
Thank you. So thank you very much. I'll be around afterwards, probably outside to take Q&A in person if you want. So I'll be around and feel free to come up and talk. Okay. Thank you.